Okay, let's take a look at two exercises. Let me take the PDF. Okay. So exercise 1.9. Each of the following two procedures defines a method for adding two positive integers in terms of the procedure's inc, which increments its argument by 1, and dec, which decrements its argument by 1. You can see here the two definitions. Using the substitution model, illustrate the process generated by each procedure in evaluating plus for 5. Are these processes iterative or recursive? So let me take VS Code. VS Code, here we go. Okay. VS Code. Okay, so exercise 1.9. So we have to compare using the substitution model the two different definitions for the addition of A and B. We have this first definition, and we have this second definition. As you can see, the difference, the definition, the F part is exactly the same, since if A equals 0, then the procedure returns B. These in both the definitions. What the difference lies in these two lines, line 8 and line 15. And this is a beautiful exercise because the two procedures compute the same result but generate very different processes. Let's start with the first one, with the first definition. And if we evaluate plus for 5 using the substitution model, we can see that we have the expansion and then the contraction typical of recursive processes. This is because basically we are building up a chain of deferred operations. So the operation inc that increments its argument by 1 is deferred. And only when A reaches 0, the interpreter starts applying those pending operations, those pending increments. So we are in the case of recursion. This is a recursive process. This is an important distinction that is remarked in the book. The procedure calls itself, and so we have a recursive procedure, but more importantly, the process is recursive because it grows and then it shrinks. Instead, if we look at the second definition, that is this one for line 46 to line 49, and we evaluate plus for 5 again using the substitution model, we see that there is no expansion and there is no contraction. There are no deferred operations, and at every step, the state of the computation is fully captured by the current values of A and B. So this is an iterative process. The key difference is this. In the first version, after evaluating plus dec A B, the interpreter still has to remember to apply inc. In the second version, the work is done immediately by transferring one unit from A to B, decrement A, increment B, and repeat. And so this has been a nice exercise to remark the difference between recursive and iterative processes. Exercise 1.10, it's more concrete in a sense. We have this definition. I don't remember the name of this mathematical function. Let me take the PDF and I'll tell you. The following procedure computes a mathematical function called Ackermann's function. Okay, and basically we are given the definition of this Ackermann's function, and we are asked to evaluate the value, to find the values of the following expressions that are the ones that you can read here. So A110, A24, and A33. And here I can show my terminal. Get bracket x110.rkt, and we can easily compute the values for these procedures, 1024 and 65,536, and I can observe that these are powers of 2. But then the second part of the exercise asks a different thing, that is, consider the following procedures where A is the procedure defined above, and give concise mathematical definitions for the function computed by the procedure f, g, and h for positive integer values of n. For example, Kn computes 5n squared. Okay, and here it's very easy to find that fdn can be reduced to 2n, gn can be reduced to 2 to the power of n, and instead hn is a power tower of 2. Basically is a repeated exponentiation of 2. So this is not a great exercise, but still I did it, and I showed it to you. Okay, that's all. See you in the next video.